Okay, this is a continuation of a couple of the problems that we were doing in class today in section 1.2. We wanted to look at part C of example 1. So I'm going to scroll down to that. We're trying to simplify this expression. Notice that the two radicals are split up into two separate radicals right now. They're both square roots separated by a times. And since they're both the same root and we're assuming all variables are positive, we can then move this into multiplying it together to one radical. So 3, you just multiply piece by piece. So 3 times 6 is 18. A squared times a to the 5th, we add the exponents, that'd be a to the 7th. And then b cubed times b to the 1st would be b to the 3 plus 1, which is 4. And then we ask, can this be broken down? Well, we're looking for square roots, so let's think about some perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Past that, you'll be bigger than 18. 9 is the biggest one that goes into 18 evenly. So we can break this up into 9 times 2. We learned a shortcut, remember, for how to do the variable parts. So the square root of 9 is 3. The square root of 2 is going to stay inside the radical, so I'll go ahead and put that still in there. 7. So this number is understood to be a 2. So 2 goes into 7 3 times exactly. That means we have 3 groups of 2 inside there that we can pull out an A for each group. And then 2 goes into 7 3 times like we said, but with 1 left over. So there'll be an A to the 1st on the inside. 2 goes into 4 exactly 2 times. So this will be B to the 2nd with no B's left over inside. So 3, A to the 3rd, B squared on the square root of 2A. Looking at example 2, we don't know whether or not x or y could be negative or a, and that should be all variables. Assume the variables may be negative because we didn't even use the letters x and y, so that's a little bit confusing. So simplify the expression assuming the variables may be negative. So essentially what this means is we don't know if the base of each of those, remember each variable here is a base, if it's a positive number or a negative number, because remember a variable is just kind of a placeholder for a number. So when we're doing these, remember that even roots, if the variables may be negative, we're going to need to use absolute values on things outside an even root. So square roots, fourth roots, any of those. So for this first one, yes, we're going to have to worry about possibly absolute values. So we can first ask, is 81 a perfect fourth? And that actually is a yes, because 3 to the 4th is 81. So this would just come out as 3. We would then say, okay, 4 goes into 5 one time. So we're going to put this in an absolute value. The 3 does not need to be in an absolute value because we already know that the 4th root of 81 is 3. There's no question on what that base is. But since we don't know if r is positive or negative, that one r that we're going to pull out is going to be in an absolute value. There's going to be one r left over, so we're going to have still an r inside our 4th root. 4 goes into 8 exactly 2 times, so we'll have s squared, and you can think of it being in its own absolute value. And then there's no s's left inside, so this is kind of a little bit too long right there. But the big thing to consider here, and there's 2 different ways you could write this. So this is just kind of us showing you how to work it out. So this could be r and s squared could both be in the same absolute value. But s squared is absolutely always going to be positive because you're squaring whatever that base is. So technically, it's more correct to have just the r in the absolute value because that's the only one we don't for sure know if that would turn out positive or negative, because if you square something, it's going to turn out positive. So I technically accept either version, but we don't test you on this on the exam, so it's not too big of a deal right now. But if you're going on, you would have to worry about something like this because it's really knowing and understanding your variable and how the parameters on your variable change if you talk about it being positive versus negative. Okay, so let's look at this next one. So this would be cubed root of 8, a to the 6th, b to the 3rd. Now, because this is an odd root, we don't need to deal with absolute values at all. It's only when you have even roots and the variables may be negative. So the cubed root of 8 is 2. 3 goes into 6 exactly 2 times, so a squared will come outside, and 3 goes into 3 exactly 1 time, so b to the 1st will come outside. So this already was a perfect cube underneath the radical, so it comes out completely as just 2a squared b to the 1st. And like I said, we would just do these 3 in the video format. We're going to pick up with rationalizing a denominator in class on Wednesday.